So why is AI important? Of course, there is a lot of hype around AI, but it's also a lot of substance around AI. So if we know what we're doing, this could really bring business to Ericsson. And from PricewaterhouseCoopers, this statement was made last year around AI predictions. So artificial intelligence has the power to change almost anything about the business and can contribute to about up to 15.7 trillion to the global economy in 10 years. And I think that's a huge number. It's the largest number I've heard so far. And of course, it's a prediction, so we don't know how accurate it is. We don't know the prediction model and the accuracy of the model behind. But I think, I mean, the point is, this is super important. And I think Ericsson, like Sachin said before, we have been doing research in this area for, I think it's more than 10 years. And we have tried it in many different ways. We have explored what can we do, how is it helping us. And I would say one of the things we have found along the way is that every time we have estimated a certain value of an AI or machine learning capability that we have created, we have always underestimated how much value it can bring. So if we think it's going to improve with 10%, it's always shown to improve 15, 20%. So I think we are still, though it's a hyped area, we are underestimating how much value it can bring to us in so many different dimensions. It's not just efficiency gains. It's about new business, growth, evolving current portfolios, and so on. So we have to really understand how to think about AI and what's needed to make this a reality for Ericsson and in the portfolio. Okay, so the content today that I will be talking about is explaining a little bit about why this complexity is not only creating a kind of an opportunity for AI, but it's a necessity to use AI. And also how we at Ericsson are using AI, so examples of solutions that already exist, that is ready to sell tomorrow, because that is the truth. Many people come to me and say, what's the status, what's happening, is there something ready, or is it still something we talk about and that we have in the labs? But we do have real solutions in live networks today that are working and bringing value to our customers. And I think that's super important that we understand that this is actually happening now. It's not something in the future. In the future, we're going to expand from where we are today, but everyone needs to know what are we doing today and to be able to explain to our customers around this value. Today, I think we are too few that can talk about AI to our customers more than 2 minutes. Then we get a question and we feel uncomfortable. We have to have more people feeling comfortable about explaining AI, not to the nuts and bolts, but from a business perspective, and also proof pointing, the value that it's bringing. Okay, so of course the main driving force behind what's happening is the focus is shifting from the operators needing to operate products to actually deliver service. And when we deliver service, we have to understand much more. We have to think about the operating networks differently. It's about understanding what is the behavior that we need to support and how is this behavior changing. If we don't understand the driving forces and the needs that the end customer has, it's going to be very difficult to predict that and be there to support that when that need occurs. We have to move away from being reactive to a problem to actually predict the behavior or need that's coming and have the solution that can adjust to that automatically, but also using AI. So that is transforming the way we think about operating networks. And operating the networks from an experience-based approach also becomes more difficult now when we are seeing multi-technology setups in the network. We have an enormous growth of traffic, more devices, but also the operator view of the services that they need or the expectations of performance and stability is increasing too. So all of this, when it comes together, it becomes too complex. The human brain can't really manually figure out how to adjust to this and predict what's going to change and when and how to meet these demands. That's where we need the help of the machines and math. So I just wanted to kind of pinpoint this one. It's taken from a managed services presentation, but I think it's important because traditionally, when we had a problem or when we have complexity, we have thought, oh, we need to hire more people. We need to throw more people at the problem. That will help us. That is no longer the case. It won't help. More people won't help. It will actually make it even, less good. Because, and why is that? Well, when the complexity is increasing this much, and when we have also these fast changes that we see, it's no longer a people problem. It's a system problem that we need to work with. And we need to work more with the data. We need to really think about how can the data help us understand this complexity and these changing behaviors. And how can we make sure we put it in an algorithm in the network that can actually detect these patterns that lead to these problems or that demands rapid changes in the network. So the algorithm will help us detect it and prevent problems from happening or adjust the network to the increasing demand that we can see. So we have talked about AI now for during Yogesh's presentation around what is AI. So I think you have a pretty good view. I mean, also the maturity, of course, of the crowd here today and on the webcast is very different. So some are less familiar with AI and some know more. But just to be, taking a step back and saying, okay, so if we now understand AI, how do we actually make that work for Ericsson? How do we do that? How do we do that and how do we get there? So taking a step back, I wanted to kind of start thinking about, the different pillars. You hear that we are doing this embarking on this digitalization journey for Ericsson. What does that mean? We tend to talk about different programs and focus areas, but we don't really put it into a context. With this view, I want to kind of share my thinking around the different fundamental parts that we need to have an understanding of and what is dependent on what here. Because when we talk about machine learning development, we can talk about the techniques for that, we can talk about different algorithms, the competences we need, that's very good. But again, someone raised the questions, what do we do about the data? If we don't have the data available to us, it will be very difficult to get anything done. And there are also other parts. So these 4 parts here, digitize the data. I mean, it's not something new to Ericsson, of course. We have been on digitizing data for a long time from a kind of network system perspective. But digitizing data is also about thinking about I'm convinced that if we're going to truly think data-driven and truly get to a situation where our whole portfolio is thought from a data AI design perspective, we also have to embark on that journey ourselves. We have to think about data-driven business in our own day-to-day work. So using data in a different way, it's not something that happens at the end. That's how we traditionally do it. We think about data being something of like a byproduct of something else. We create a function and then we check the data afterwards, instead of actually using the data as input for the whole function or actually understanding what the function should be focusing on. So the data is the starting point of everything. That's kind of my main point here. So without digitizing the data, we can't automate, we can't put AI on it, we can't understand patterns, we can't analyze and explore, right? So digitize the data and set the foundation from there. Once you've digitized the data, you can take any of the 3 other steps here. So it doesn't mean, for example, from a company view or from a BA view, let's say for the whole portfolio, that you have to do that for everything before you can actually get to the machine part. But it means that you kind of, for every solution you're creating or for every problem you're trying to solve, you have to follow these 4 steps, basically. So think about digitizing the data and transform towards a data-driven approach. So how can I use the data in a different way than we have before? So starting point, what do I see? What can I learn from this? What is the data telling me? And then you can think about automating workflows once you understand that, and then you can apply machine learning if it's needed. Someone asked also the question, when is it not needed, or when does AI and machine learning not work? I think most cases machine learning works, but we shouldn't use machine learning if it's not needed. So in many cases, we don't have to go for the most advanced methods and techniques. We can solve a lot of Ericsson's and our customers' problems today by just simple data correlation, simple analytics, and static models. That will take us a long way. That doesn't mean we shouldn't explore and use other more advanced techniques too, but we don't have to apply that on everything. That's unnecessarily expensive. It's also, if you think about computing power required to run advanced models, that's also something we should think about. Power consumption, the environment, all of these things, also time consuming and so on. So when we can solve a difficult problem with a simple model or a simple solution, we do that. When we need more advanced techniques, we do that. So we should really think about what's needed when. So what is actually digitizing data? It might sound like everyone should know that, but it's actually sometimes more difficult than you can imagine. The simple part is the lower part here, of course, documents that we have. We need to think about creating data out of our documents, because when they're in documents, of course, you can use text analysis and so on, but it's more cumbersome, it's less available to people, right? But digitizing data so we can actually use the data inside it. For example, customer contracts today are documents. If we can turn that into elements in a database, that would be very helpful. Also, when we think about combining that with information like installed base, so in our customers' information or from the network in terms of what software is being used, what configurations, what hardware, and so on, combining that with the contracts, for example. I mean, I've been involved in several customer discussions with European customers where we actually realized that it's still the situation that in many cases everything is in Excel. You can argue that Excel, if you have it in Excel, it's data, but we don't use it like that. We use it more like a document. And many times the customer has bought things we haven't, maybe they themselves haven't turned on or activated in the network, or we haven't done that either, because we have poor control over what's actually in the contract versus what's actually activated on and actually up and running in the network and so on. So it's just a little bit of an example, but I think in many cases we are lacking the kind of holistic thinking which we would get if we had better access to data. The other part is the kind of how do we go from the knowledge people have in their heads and digitize that. That is a journey that Managed Services has worked on for a couple of years now. Turning knowledge from people's heads into to not only data, but also improving processes, improving ways of working, understanding how to automate things. So things that were manually done before, now we can actually turn that into a flow that is actuated by a machine. So we can save people, save money, and make things happen faster. That's also the foundation for doing that. So from a data-driven approach perspective, many times I talk about data-driven approach and then maybe assume that people understand, but then usually I get questions on it. So I created this slide because I think it's obvious, but it's also interesting. So, so from a traditional business perspective, if you have a question like which happens on a day-to-day basis, basically. So what business should we be doing if we talk strategically, for example? In a traditional business, you would start with the point, okay, this is the portfolio we have, how can we enhance from that? But in a more data-driven approach, you would instead think, okay, what is the data telling us? The typical example here is Google. I know Google has another business model and it's different, but if you think about the data-driven approach they have, they actually continuously look at the data and what is the data telling Google, and they are prepared as well to act on that. So many times they've seen that if they're currently doing business here, but when they analyze the data, it's telling them they should actually be over here doing business. They are actually acting upon that and actually steering the business towards that. They might not, of course, take away what they have, but at least they invest in that area and see how will that pan out as the next step. From an Ericsson point of view, yes, we try to be agile like that and flexible, but many times we are not because we're not trusting the data. So that's another thing. Sometimes we have the data, we look at the data, we analyze the data, but we kind of come to the conclusion it can't be right because maybe isn't this complete or is something wrong with the data and so on. So we have to start getting to a point where the quality is so good that we can trust it, and also have a mindset that maybe the data doesn't have to be 100% perfect to be trustworthy. Maybe we can trust it anyway. Okay, next one, base for business decisions. In a traditional business, it's a lot about experience. according to my experience, I know this will happen if I do that. So that's kind of the main thing that steers my decision making. But in a data-driven approach part, it's more, okay, what's the data again telling me? What's the insight I'm getting from there? What's the predictions I can see we are building here? And be able, again, to trust the data, trust the insights, dare to take a decision that's not maybe based on what you would have thought from your experience was the correct decision. Or a combination, of course, is needed. So how do you get things done in a traditional business? It's very much about, okay, in Ericsson at least, we start thinking, okay, we're going to start something new. Who's going to own that? How it's going to look like? How it's going to be set up? Who's going to pay for that? All of these things before we do anything. But in the data-driven approach, it's more enablement. How can we enable things to be done? How can we enable data access? How can we enable teams to empower the teams? How can we make sure there's an infrastructure underpinning what we need to be done, so that not the first thing the team needs to do is to find the data, set up the infrastructure. You know, half a year later, they still haven't gotten started because they are stuck on these kind of enablement needs that haven't been met, right? Next one, so focus during execution. So once it's up and running, what do we do in a traditional business? I'm not saying that, by the way, that Ericsson is all gray here. I'm saying that we still have a lot of this left in the organization. We're on the journey, but we're not there yet. Okay, so focus during execution is very much, okay, which tools are we using and how do we get these to work together? It's an integration approach in many cases. While the data-driven approach is, okay, so how do we make this happen through data models and algorithms? So tracking progress. In a traditional business, it's more about, okay, these are the things I need to know during the project, these are the KPIs, and that's what we report on. But in the, again, in the data-driven approach, we should be looking at the data, not having the assumption that we know what's going to be important to track, but actually looking for what is the data telling me is important here. Maybe there's a deviation from another dimension that I haven't thought of when I said these are the reports I want to see. So again, be open to looking at things from different perspectives. Finally, how do we increase productivity in a traditional business? Well, it's a lot about, okay, we need to do things faster, improve the process, maybe get a new tool. That's how we kind of think about things many times. But in the data-driven approach, it's like, how can we use data? Is there data we're not looking at that could help us? And how are we actually looking at and using the data? Can we automate? Can we put in AI? This part we have done much more with internally as an organization, but also in our delivery capacity, which is great. But we can do even more. And we can think about this in, you know, on a day-to-day basis. How can we think about this differently? So this is an example I took from Managed Services too, because I think the journey that Managed Services has been on is an excellent example of how it's possible to transform an organization which has worked very reactively, very traditionally, very human-driven, people-oriented, to something that is now completely different, much more proactive, predictive, preventive, and also data-driven in a completely different way. But it requires top management support. It requires a full scope of the organization being on board to get this change. This is a typical example of what has changed in Managed Services. So the traditional flow here is that you have this alarm or customer complaint coming in, so we're waiting for that to happen. And then we register that as an event. We do an analysis of the event. We create a ticket to solve the problem. We act on it remotely or send out this dispatch a truck to solve the problem. And then we complete the task, right? That's how we traditionally have done Managed Services. But now, instead, the starting point is data. So how can we think about, how can we look at what happened in the data, in the network performance, for example, before that actual event happened, before the alarm was triggered? What happened? Can we find patterns in the data indicating when these three things happen at the same time, this is very likely to happen? And when we start building algorithms that can help us and models that can help us find these things and put them into action, we will be able to actually put the prediction models in place. We'll be able to proactively detect these problems and then have a proactive insight. Okay, we need to do something now. And hopefully the window is large enough so we can actually have time to act before it happens. And then instead of actually having the event happen, we can detach the event and and make the analysis of what needs to be done, we can still create a ticket, because remember, it's important to, although we are preventing things from happening, we must be able to prove how many things we have prevented and what type of things we have prevented, so that the customer can see, instead of actually solving these things very quickly, we have prevented these things from ever happening, which is of course much better, because if the network never goes down and you don't experience any problem, even if it's solved quickly, the ultimate goal is of course to have a stable, consistent performance over time. That will increase user satisfaction more than anything, I would say. So what happens after, of course, is that you get the preventive action rather than a resolution action. And also we have added a feedback learning back to the data and the models and so on, so we can improve them over time and see how often were we right. Can we increase the prediction accuracy based on improving and tuning the model and training the model on new data and the results of our actions as well. So just keeping time here. Okay, so from an automation and automating workflows perspective, you've probably seen this many times. I did some changes to it because I added the blue part here just to kind of, in the beginning when this picture came out, to talk about the kind of how we move from scripting towards human-guided automation, where we actually have a person deciding if we, what solution to use, to more sort of say complex automation, where we have full closed loops of automation, still human or rule-based automation, where we have decided how it should be automated and so on. People started saying to me, oh, so the only reason we're adding AI is because we want to, it's kind of the optimized version of an automation. And that is, of course, not true, because we can use AI for many things, many other things than just optimizing how we automate. But it's a very important part of the automation journey. So, and it's definitely needed to come to the full extent of what we can automate. And why is that? Well, as long as it's humans deciding how should the workflow go and so on, we bring, for example, we bring bias to that equation, because we are used to thinking, I've done this for 20 years, yeah, and this is how we always do it. It always starts with this, and then we do that, and so on, right? But when we actually think about having a machine learning helping us and using the data to optimize these things, we will find that maybe the things we have always been doing is not the right thing to do. So it's going to, without the bias, if we do it correctly, of course, we can of course enter bias into a model too. But with less bias then, we can then find ways to optimize how the workflow is done. Maybe skipping things we thought, steps that we thought were necessary, or doing things in another order will also optimize things. So adding the machine learning part, and then also the machine reasoning, the logic, and so on to automation, we will bring it even further. Okay, so Yogesh talked a lot about AI, and I won't go into depth on that. I just wanted to bring up some of the techniques, because Yogesh didn't touch so much about that on that. And I think many times when, at least when I've been in customer presentations, I get questions, do you use deep learning in your systems, for example? I don't know how familiar you are with different techniques, but deep learning is a pretty advanced technique, one of the most advanced that we have, that is being explored on or researched on, you could say. Today, there are deep learning models live in the society, but they are not so many. And I'll start with the most advanced one, and then I go backwards. And the reason why we would get the question on deep learning, for example, first of all, customers, sometimes they ask the question because they think that's the coolest thing you can do. If we're using if we're using deep learning, then we are really doing cool stuff. But they don't really understand what it is. The other reason they might ask it, if they understand this technique, they would also know that deep learning is one of the techniques where we cannot actually explain afterwards how the model helped us reach a decision on something. The transparency it's really a black box what happens when you use deep learning. And if possible, I think it's something we should not use if we don't have to. Sometimes it's really needed because we have really complex problems, until at least we have more until there is more availability of kind of explaining, if ever, right, how we came to certain decision. I mean, there are legal reasons for it, of course, because laws are in place and then the regulation around using data and AI is just increasing. We have to be able to explain a lot of things around using models, like what data is being used, how is the process, and then the decisions as well. Today, there is not a law that says that you have to explain every individual decision, but it could be the case. You never know. So let's not build complexity into our systems that we don't have to. I would say majority of cases, of all the cases we have now and in the loop, are using mainly machine learning techniques, more the simple things. Some customers might also ask or comment, is this really machine learning? Isn't it just analytics? And you should not be afraid of that question. The only thing we should be careful with is to say that it's machine learning if it's actually analytics. It's nothing to be ashamed of, because I think if we can solve the problem with analytics in a better way than the customer solved it, we have succeeded. And we should be able to say that proudly and say, yeah, but we've solved the problem. Why should we use that technique if this is helping us solve the problem? So just keep it separate. So when we have dynamic learning and using machine learning techniques, that's one thing. And when we have more static analytics models that don't change, that don't learn over time, that we actually set the parameters for, that helps us solve the problem, that's fine too. So don't mix it up, but don't be ashamed of saying it's an analytics model if it is an analytics model. It solves the problem. That's the important thing. I wanted to kind of, again, Yogesh touched upon the difference between machine learning and artificial intelligence. As you see, there is a floating border in between these two. So there's nothing you can say, you can't really say this is pure AI, this is pure machine learning. This is also, the definitions are debated in the industry as well. But there is, to the right is more like when it's driven by facts, knowledge, and managed by logic, that's more on the AI side. And to be honest, when we talk about AI, we're mostly doing machine learning. So but it's a natural evolution because you kind of move from the left to the right. And it's fine. We are solving so many problems, and we can be solving so many more problems just by using analytics and machine learning. Okay, so I wanted to bring up these as well. I mean, we've had in place for a while from kind of AI machine learning perspective, that an ambition that we should be using machine learning and other artificial intelligence technologies to create data-driven, intelligent, robust solutions for automation, evolution, and growth. And I kept these words because I think they also fit very well with Eric's overall strategy, which is, if you remember, the relentless efficiency, which is automation, of course. And then we have end customer experience, which is the evolution of our current portfolio technologies to increase the end user experience, end customer experience. And the growth is the new revenue streams, right? So it fits with these three ambitions as well from a kind of a machine learning AI perspective. So when I go through the examples today in the session, I will be using these three to say what area are they mostly targeting. It doesn't mean it doesn't target the others too, but it's a main target per use case. So, yes, let me see. So now we will go through some of the use cases. Okay, so we will be running a short video here. Yeah, so I can just, when they're setting things up here, this is a short video of Ericsson Operations Engine, and some of you might have seen that, heard it. This is the short version. It's just, again, coming back to, it's possible to transform a very traditional, reactive, human-driven operation to something that is data-driven, automated, on a high degree, and much more modern, targeting the outcome rather than the actual service itself. Yeah, I wanted just to inspire you a little bit. Yeah.
When you imagined the future, did you imagine this? Neither did we. In 2019, Ericsson introduces the Operations Engine, rewriting the rules of network operations through automation, artificial intelligence, and the power of data. From enabling the big things like industrial IoT and smart cities, to the small things like keeping you connected here, and even here. It's an intelligent, sustainable, and better connected world, made easy. Let's stop imagining the future and start driving it.
Okay, so I just wanted you to get a little bit break from all the PowerPoints, but also to be a little bit inspired. I mean, this is of course advertising, so it's not saying so much what the operations engine is. But I still think it's a really, really big improvement. I just want everyone to be aware of that. It's sometimes we do changes in Ericsson, and everyone's like, once they understand, it's like, but it's the same thing. Well, it's just a new name, right? Nothing changed. But this has changed. And I would really also like to actually give credit to Peter Laurin, head of BMOS, BA Managed Services, who has really dared to change. He dared to change everything. Because when we were working on this, I was helping out running the program and adding the data-driven approach. I was saying, you know, it's going to have to change the operational model, the commercial models, the price models, people, competences, how the organization looks like. Everything has to change, truly, if we're going to be able to deliver on this. And that's also the journey I think Ericsson needs to take as a whole. We have to think about what does AI and data mean to Ericsson, and how can we use it much more efficiently and take it seriously. It's not something on the side. We can always do proof of concepts. We can do create amazing small solutions, and that's basically what we have been doing so far. We have been exploring, oh, it works over here, it works over here, but we haven't really taken the strategic, holistic view of how can we take this to the company for real. And I think what's happened in managed services is a very excellent example of that. It's changed everything. It turned everything upside down completely. And the focus of the services is now the outcome. What will the service lead to? And not just delivering a certain service to a certain number of KPIs or fulfilling SLAs, right? It's changing everything. And I think it's super exciting. I think we have just seen the start of that. And let's look at some of the cases that have been developed so far. So these are, from an operations engine perspective, 18 AI-based use cases that are live and deployed in customer networks. And as you see, they cover several different areas, and they are also, I mean, what you could think about when you see these, I mean, I think it's pretty impressive, and some of these are also, of course, using Gaia competence to be developed, but it's also other teams across Ericsson. And I think Gaia has helped a lot in accelerating this journey, accelerating the understanding, bringing in new competence to Ericsson, because it's very difficult to find experienced data scientists in the market. It's virtually impossible. To attract people, you have to have a combination of basically access to data, the environment to work in, but also complex, interesting problems to solve. And I think Ericsson has those three things. We just need to be better at leveraging the data, setting up a more common, easily accessible infrastructure that will help us and not hinder us, right? But on the complex use case side, I think it's very attractive from a data scientist perspective to come and work in Ericsson, because, to be honest, it's so complex that it also requires a lot of domain competence in combination with data science competence, which is also a complexity in itself, right? So, but again, I marked it green as focusing again on automating as much of the decision making and the identification and predictiveness and so on. But it's also bringing, of course, a lot of value in terms of new revenue into Ericsson, for sure, improving our margins as well. Here is another 22 use cases that are developed that hasn't been put into, they are being forward or in FOA or trialed or tested right now, but they're ready to run. But the previous slide was ready to actually roll out anytime because it's already up and running. I wanted to kind of just dig into one of these use cases, which is called the wrong KPI degradation. This specific use case we have It's multi-technology, so 2G, 3G, 4G compatible. It's also multi-vendor, Huawei, Ericsson, Nokia. From a usability perspective, it's really good. I mean, the idea with this one is to predict, of course, degradation in throughput and latency on the RAN side. And it can predict 18% of total cells impacted per week, which is pretty impressive, I think. And the model itself has an 82% accuracy in the predictions based on the different deployments we're seeing. So this goes up and down a little bit, this percentage. It's not something that's fixed depending on the feedback we're getting. And remember again that when we're using these models and when we develop them and train them like Yogesh talked about and then put them into live operations, it doesn't mean it's ready. It's not like software. You deploy it and it's there and it waits for the upgrade to come or the new release. It's actually something you have to continuously monitor in a different way than you monitor software, because software is static. So once you've developed it, tested it, and released it, it acts the same way regardless of what's happening in the network, basically, unless it stops working. But I mean, here the thing is that the model is adjusted to a certain training data set that you had when you trained the model. And if the behavior starts to change in the network, other apps are starting to be used, or there's let's say, depending on what happens, maybe it could be different patterns of how people move. There is a construction, or there's infrastructure changes, or a new neighborhood is being built up and so on. That could impact things that actually makes the model less good at predicting what's going to be happening in the network, right? So that's why it needs to be continuously monitored in terms of accuracy and predictions, but also if it's no longer valid. So we have to think about setting thresholds when the prediction goes down and the performance of the model goes down. So maybe we say warning threshold, it's now less than 70 or 75%, and then going below 70%, maybe it's no longer valid even. So we have to think about these things and having monitoring of that. And there is also an important part of this, which I will come back to later, but we have to think about the competence on our support, in our support organization, because supporting software and supporting models, machine learning models, is different as well. So you have to be able to see, do we have a data problem or do we have a model problem, for example, if we are seeing problems due to an AI functionality that is not working. So that is also an important part of this. And then, of course, then the prediction or the prevention that we want to do, or the correction in the network, the configuring of it, 70% automatically prevented by the model itself. So no human needing to go in and take a decision and then do something, but it's actually handled by the model itself. So I wanted to bring up this one too. This is a very new slide, but it's not a new case. It's these figures here are coming from implementation. I brought it up. I have two climate-related use cases, because I think it's important. It's coming more and more in terms of we are worried about the climate, but at the same time we're also providing solutions that is helping our operators to achieve and reduce the climate impact here. So in this case, it's called the energy infrastructure operations, and typical savings per site on grid energy savings. You see the site availability per month going up, actually, while the site maintenance cost is going down. So this should be interesting for any operator. Considering the big US operators as well, we're talking a lot. I know, for example, on AT&T side, I know they're one of the biggest power consumers in the US. And I guess it's similar to the other tier ones. So, and 64% down in power-related outages, and also the reduction of the CO2 impact. So I think these are compelling, interesting problems we're solving, and we should be doing even more of this going forward as well. Okay, moving over to the RAN side, what's happening there? Last year, they launched a new ambition called AI-powered RAN. What does that mean? Well, it's an AI model optimized for RAN compute with zero capacity loss. It's one of the the parts of this, and then continuous learning on the node. So it's happening on the baseband itself, so it's not central, but it's actually pushed out with instant feedback loops and quick adaptation of traffic trends. So why is this important? Why do we want to do the? I mean, you could argue that from a telco perspective, this is sort of an edge implementation, because what will happen is that when you're on the site, of course, there are different contexts. So if you think about software, you put the same software across the whole network to do a certain thing, right? But if you put a machine learning model on the site instead, that machine learning model will be able to adapt to what's happening in the cells for that site, right? So if there is a change, let's say traffic density during the day, for example, might be very different in one site to another site. And then the model will actually be able to adapt to that over time. So knowing that this is a lot of high ARPU users in this cell at this certain time of day, or there could be other things that the model can adjust to depending on, of course, the objective of the model. And there is not only one model, of course, there's a multitude of models. I should say one thing, by the way, that I forgot to say. So far, both in the industry and in Ericsson, the solutions we have built are standalone. So we only see AI models solving a certain problem and not working with other AI models to achieve that. So within a model, the objective of that one is not to work with another one to achieve the goal yet. But so far these are isolated and they're very spread out. And that is also something we strategically need to think about, how we move to a situation where we can have several layers working together. It's very complex, of course, but that's probably the next thing we're going to see. And it's probably not going to be that long until our operators say, I want this model to be compatible with this Huawei model or this Nokia model. And we need to make sure that they can work together like a nested setup of models. But that's not happening yet. But just so you know where the evolution is at the moment. Okay, so the foundation then of the AI-powered RAN is a future-proof RAN compute architecture. So this has really been thought into. I mean, it's happening. It's been launched on LTE, but it's also, of course, empowering 5G in this space here. Right? And all the AI models based on data from the field and trained on that. And it's also partnering with service provider and device vendors as well. So this is taken seriously. It's not been something that RAN has been super clear about how this is being done. But it's actually, okay, I moved directly into the case. Okay, let me actually go to this one because, yeah, so I wanted to show these 4 ones because these 4 examples here on advanced traffic management and evolved carrier optimization are now features in a RAN AI-powered feature package, which they have packaged separately. So it's not part of the software buyout, but it's actually packaged and priced separately from the traditional one. And why is that? Not all of the RAN ML features will actually be sold like this. The ones that are more basic, enhancing LTE, for example, to show our capacity and competitiveness in LTE will stay as they are. But basically, the ones that show very high value, where we can have a value-based pricing and really show using these models will actually achieve this. Again, the outcome-based focus, the value-based pricing, is following that trend, right? Then they will be priced and sold separately. So how do I go back? Let's see here. What's the time? Yeah, actually, maybe I should. No, okay, let's do this one. I wanted to bring up another one. So even in RAN, from an AI perspective, there is an enabled energy efficiency case here. They have several software-based ones, but they also have AI-based ones. So the challenge here, possible to save power by disabling MIMO during periods of low traffic and current functionality thresholds based and statically configured. So that's what they wanted kind of to change again, to see, can we, rather than having human-defined and static thresholds for this, can we get machine learning to do this dynamically and optimize it depending on location and situation and time and all of these things, right? So the solution is use real-time traffic predictor to dynamically adjust configuration for maximum energy saving. And then benefit is, of course, lower power consumption without negative traffic impact and lower OPEX, so 14% savings per site. So if you start counting now, if we're doing things on a network level for managed services, and then we're doing things on the RAN level site-wise, and if we start thinking about all the places we could do these things throughout the network on different products, right? It's a very interesting case, and I think Ericsson should be proud of what we are doing here, because this is very important. And it's going to have a major impact. And we should do more and talk more about this, I think, too.